On this video, what you're going to be doing today is graphing the tangent functions. So we'll start with that, and then afterwards you're actually going to calculate, or we'll talk about what the period and the amplitude is of the tangent function. And then also you're going to be doing a couple of graphs in a similar way to what we did with the sine and cosine functions, and then talking about period and amplitude, what actually changes those things. So to get started, we're just going to graph the tangent function. So you probably you should have out your piece of paper with the gave you the axis for graphing these functions, and then we'll make a table of values like we did before. So just starting off, as you can see here, we're going to make a table of values for y equals the tangent of theta, starting with letting theta be 0, and just continuing around our unit circles we have from 0 all the way around to 360 degrees, using every one of the angles. So just going back up to the top here, if you want to pause the video, you can, but we're starting at 0, 30, 45, 60, going all the way down to 360. And again, feel free to pause the video as you need to copy these things. So we'll start now that you have the table made. We'll start at 0 degrees. Now, to actually remember your unit circle is pretty handy for this, because as we talked about, the tangent of theta is just the y coordinate over the x. That's what we figured out in class. So we'll be doing a number of those, using that quite a bit. So if you just start with your unit circle and look at the coordinates here, what you have is you're going to put the y coordinate over the x coordinate. Well, y is 0, x is 1, so we have 0 over 1, which is just going to be 0. Pretty easy there. Then we'll take the next one, 30. So it's y over x. Now I'm going to write this, going sideways. What we have is 1/2 over, now we have the square root of 3 over 2. So I'm entering it this way because we'll put it into a calculator. Now on your calculators, I'm using the parentheses because that's the way to make sure this calculates correctly. 1 divided by 2, right? And then we're going to divide that by parentheses again. We're going to take the square root of 3 and take that and divide it by 2. All right, so when you hit this, you should have, it's going to be about 0.58. So we know that that's about 0.58. So I should use my approximations here. So let me go to 45 degrees. Well, that's the square root of 2 over 2 divided by the square root of 2 over 2. Well, you don't need a calculator for that one. Same on the top and the bottom. That's just going to be 1. So now we'll go to the next one for 60 degrees. Well, that's y over x. Y coordinate is the square root of 3 over 2. And we're going to divide that by 1/2. So if you do that in your calculator, so we just take the square root of 3 over 2 and square root of 3 over 2, and we're going to divide that by 1/2. Now, some of you might be able to do some shortcuts and some things, to do that. But basically, your end result is you get about 1.7. So that's going to be our value there. All right. Now if we move on to 90 degrees, this is where we get a little crazy, as our y coordinate here is 1 and our x is 0. Now that's not 0. Remember, that means it's undefined. All right, so at 90 degrees, the tangent function is undefined. So if you try and put that in your calculator, you're actually going to see that it doesn't, you can't do that. So what we start taking a look at next is, what if we do 120 degrees? Well, if you use your unit circle here, you're going to see that that is the square root of 3 over 2, right, divided by, and in this case, the x coordinate is negative. Well, we've already done that same problem up here, notably right at 60 degrees, right? But the difference is it's negative. Well, that's just going to change this to a negative number. Then we go on to 135. You have the square root of 2 over 2 divided by the square root of 2 over 2. And excuse me, the x-coordinate here is negative. So basically it's the same as the 45, only it's going to be negative. Going on to 150. So if we go to 150 degrees, so 150 we start to see, we're maybe noticing some patterns here. That's a half divided by the square root of 3 over 2. Well, we've already done that as well. That was actually back at 30 degrees. Oh, excuse me again. The x-coordinate was negative there. So, it's the same as 30 degrees only with a negative. And we realize that number is about negative 0.58. So far, we've calculated those. And then we go back to 180. Now, in this case, it's 0 divided by negative 1, which is still just going to be 0. So at this point, just continue on around the circle, doing these same types of things. You notice the next one, if you continue to do these, and I would encourage you at this point, to just pause the video, do the rest of the calculations, make sure you know how to do this, then turn it back on to check. Okay, now that you've completed those, the numbers that you should have come up with would be 0.58 here, or about, and then 1 for 225. Your 240 degrees should be 1.7. Your 270, again, you should have found that's undefined. 300, you would have found that that's going to be negative 1.7, or about that. At 315, we're talking about negative 1 for a value, and negative 0.58 for 330, and then lastly 360, you're back to 0. So if you have questions about how to do any of those numbers, we can address that in class on the next day. So what we're going to look at next is actually putting this onto the graph. Now, as we move here to our graph with 0 through 360 degrees, you might realize that, the largest number you got is 1.7. So we're going to put 2, and then I'm going to split this to 1. So basically going by halves each time. And then the same in the negative direction. So we'll go to negative 2. It'll be negative 1, negative 0.5, negative 1.5. So to do our calculations, we're going to plot our points. So we have 0, 0. At 30 degrees, we've got 0.58, so somewhere in here. And then 45 degrees again, which is halfway between 30 here and 60 here, is going to be 1. So at 45, we're at 1. At 60 degrees, we're at 1.7. Now at 90, what we have is undefined. So we'll kind of skip that for right now. So we're going to just leave that at this point and just move to the next ones. So then moving along, at 120, we're at negative 1.7. So we're down in this region. All right. And then we move at 135. Again, that's at negative 1. And then 150, we're at negative 0.58. 180, we're actually at 0. And then at 210, we're at 0.58. And then as we move along to 225, we're again at 1. And then at 240, 1.7. Now we hit another spot again at 270, again, where we're undefined. So we'll leave that again and skip that just for now. So then we move on to the next one at 300. So again, negative 1.7. And then as we move along to 315, we see that's again at negative 1. And then we move on to 330 degrees, so it's negative 0.58. And at 360, we're back to 0. So basically what you can see is it looks like, we've got these curves coming, and then we've got these spots where it's undefined. One thing you're going to learn, a new terminology, if you haven't heard this already before, is a point on a graph where usually it's a point where the function is undefined. What you run into is what we call that, and you mark it with a vertical line or excuse me, with a dash line. It could be horizontal as well. But we use this dash line, and this is called an asymptote, right? And it's just a line you approach but do not reach. Okay, and it's again marked with a dashed line. Now, it's usually where a function is undefined. That's what happens. So you can see as we move towards that spot where it's undefined, I'm just going to use a different color here. We start at 0 and we're going this way. It's going upward, but it can never really reach 90 degrees. It's going to get close to it, but you can't reach it because it's undefined there. Likewise, over on the right, towards the middle here, we can go towards 90 degrees coming in from the right-hand side, but we'll never get there. Again, the bell. So now we go in this direction. Again, we go towards 270, but we can't reach it. Same thing over this way. So we have our tangent function looks slightly different than the rest. Things we want to think about here. Well, in this case, as we extend the page, what's the period of this function? So as we've talked about, it's, when it starts, how long does it take to kind of start over and repeat? Well, if you notice, it's going towards 90 degrees here in the middle section, right? We have this part right along here. Starts, goes to 0, comes here. It's undefined again, but then it repeats again right after 270 degrees. So basically, between 90 and 270, you see everything, right? So if you take 270 degrees minus 90 degrees, you'll see that the period, it's repeating itself every 180 degrees. Oops, that's 90. So it repeats every 180 degrees. And you can see, if you kept going, it would just keep repeating. So amplitude in this case. Well, there really is no amplitude. Keeps going in both, keeps going in both directions. Keeps going the positive and negative direction. Basically, if you think about it, our direction, if I could spell that correctly. All right. As we've talked about before in class, the amplitudes, how far away it is from the middle. Really need a maximum and a minimum to get an amplitude, and this one doesn't have either one of them. All right, so lastly, what we've got here, for tomorrow, I'd like you to take a look at each one of the following. Y equals 2 tangent of theta, okay, and secondly, y equals the tangent of 2 theta. Remember, this first one is you take the tangent of theta, then times 2. On the right, you take theta times 2, then tangent. So I'd like you to do that for tomorrow, and then from there, basically state the period and the amplitude of each one. So we'll talk about, the shifts and things that happen with those.